How do we graph ellipses from their equations? Well, here's the simplest ellipse, and actually it's just a circle. We have a radius of 1 and centered at 0. So this is what happens. But if we start changing this, now we have 4 in the denominator. This means that clearly if I still plug in plus or minus 1 as x and then leave y to be 0, those will still work. But this 4 means that if I plug in 0 for x, I get y, if I plug in 0 for x, I get y squared over 4 equals 1, so y squared equals 4, so y equals plus or minus 2 now. So that causes this to happen. So now no longer is it a circle, but it's an ellipse that's been stretched vertically, so this 4 causes it to be 2. This is why we typically will write this as 2 squared rather than 4. Here, you see we've been stretched in this x direction, so what would it take to make this end up being 1? Well, 3 squared over 9 would give us 1. So 3 as the positive x-coordinate, and 3 is the negative x-coordinate. 2 is the positive y-coordinate, 2 is the negative y-coordinate. This gives you a simple ellipse. Forgive my poor drawing. And this is from 3 to the right, 3 to the left, 2 up, 2 down. And now if we take that graph and then shift it up, down, left, right, well, this shifts it right 5. So we go 1, 2, 3, 4, 5. Here's the center of that. And we're still saying we're going 3 left, 3 right from there, 2 up, 2 down from there. But not even that, just that, because we have to move all of that down from the y plus 1. So 5, 1, negative 1 is the center. That's what the negative 5 shifted it right. Positive 1 shifted it down. And now these 2 and these 3 give us the graph of our ellipse. So the steps that I'm using is that we identify and plot the center h, k. We identify a and b. So a is the distance to the horizontal, is the distance to along the major axis, and b is the distance along the minor axis. And then we identify and plot the vertices and covertices, so that's what these dots were, and then connect the dots. So here, let's first identify the center. The center is 2, 0. That's 2 here, 0, there. The length, so now we want to identify A is 20, so that's 2 squared of 5 is A. B is square root of 10. We've identified A and B. Identify and plot the vertices and covertices. So we use this to go 2 squared of 5 to the right and left. Well, I know square root of 20 is going to be somewhere between square root of 16 and square root of 25. So it's going to be a little bit like that and like that. So I'm going between 4 and 5 away horizontally. For square root of 10, plotting the covertices, I'm going to go up a little more than 3 and down a little more than 3. Now we connect. And hopefully you can draw a little better than I can, but I won't take off. Here, the center is at 0, 0. When we take square root of 30, that's somewhere between 5 and 6. Actually, that would be B, because this is the smaller number. A is 45. square root of 45, which is the same thing as 3 square roots of 5, but the important thing is that it's between 6 and 7. So I'm going to put those as the vertices. And there is our graph. Here, 3, 1 is our center. 9 gives us horizontally, we're going to be going left and right 3. And 25 gives us that we're going to be going up and down by 5. And now we connect. Was this the last one? No, it was not. Here we have 0, 3. A is 7 here. B is 2. So A being 7 means I go right 7 and left 7. B being 2, I go up 2 and down 2. Gives me a wide eccentric ellipse. There we go.